Baltimore. It's not just for the arid regions like Arizona or Utah that it was designed for. In general, for previous findings, they found that things, for example, like detention basins, will make peak discharges smaller, but it won't necessarily reduce runoff, which is one of the things that the Stormwater Management Act wanted to do. There's also a high correlation in summer thunderstorms with high frequency of flash flooding, which is something that we want to look at. There's also, in comparisons in the past with geisha, which is something that is typically used in Baltimore, has been used for a lot of studies in Baltimore, and that is not as event-based as Kinross is, and I'll get into more about that. And there's also been a few studies trying to compare geisha with Kinross, and what I'm trying to do is essentially, I'll show you that I validated Kinross essentially for Baltimore. So Kinross is an event-based model. It's physically based. It's distributed, dynamic, and they model the different principles of basically of a flood. And what happens is they make the elevation maps into a series of plains and streams that allow for like overland flow, so they can model what's going on while accepting like rainfall data, which that's really good because it allows you to accommodate for spatial variation. You can get a lot of really good inputs out of it for data like your peak discharge. You can calculate from that runoff ratios. You can get infiltration, which is things that are all really important to understand about a watershed that you're looking at. And I have mentioned before that Kinross is designed for arid and semi-arid regions because they're particularly difficult to model, and we're examining this as an alternative essentially to using geisha or other models in the area. These are some of the materials I used because there's a lot of data you need to input into your maps and your models. If you have any questions particularly about them, feel free to ask, but just typical ArcGIS, Agua, which is a special tool that allows you to implement hydrological models for Kinross and also other ones, and pretty much. So if you have a question, just ask, but nothing too worth talking about. So for the calibration of the model, that's like I was mentioning before, like being able to change certain characteristics to see what's going on with your model, and also being able to make it match like what happened and like better represent the area that you're doing, not just with the land use land cover maps, which are useful because they let you know what the surface looks like, where's impermeable, where's not, but those can only be so accurate. So this is really important for Baltimore because Kinross was designed for a completely different region, so you have to change things like default saturation, what the channel flow looks like. And as you can see in this graph that I have here, this is the difference between a calibrated and uncalibrated curve. And the observed curve is here in orange. The time lapse was later accommodated for, but I just wanted you to see the difference in magnitude here. The reason that you're like validated to be changing these numbers essentially is because there's non-physical constants that can vary by watershed, and that's something like hydraulic conductivity of soils, that which is like affects how much infiltration can happen, and things along like channel roughness, which affects like how fast the water can be flowing. And you also have to consider that in different parts of a basin there's different it's not necessarily completely the same, even within regions. Between like two of the watersheds I looked at, some of the characteristics did have to be different. And it's also possible to say that certain physical characteristics might be different in different seasons, which is important to take into account. And sorry, can you guys hear? I know someone's printing.
Yeah, we can hear a background. I mean, we still hear your voice fine, but there's definitely something going on.
Okay, do you want me to wait, or can I continue?
No, you can go ahead, continue.
Okay, yeah, I was just making sure you could hear me. Someone's printing like 50 pages or something. But anyway, so, oh, now they're done, perfect. So, sorry guys. So there's different, like I said, changes can happen between seasons and between watersheds, and even sometimes, so between different events, if it happens in February versus June, you know, the ground could be frozen in February. Morse Run is one of the 2 watersheds I evaluated. As you can see, this is like well within the limits of the city of Baltimore. It's highly urbanized, and it's been urbanized for a while and before the Clean Water Act. So there's not so much stormwater management infrastructure, at least not as much planning as you'll see in like more recently developed areas. It's pretty much, with the exception of this part and this part, within the city limits of Baltimore. And it's actually one of the top 10 flashiest watersheds in the United States, which flashiest meaning that the peak discharge will come very quickly after the rain has fallen. And White Marsh is the other watershed that I had looked at. And this is somewhat less urban than Moore's Run, but it's still a fairly urbanized area. And it was also urbanized slightly later than Moore's Run, so it does have some storm management infrastructure. And you can see they're pretty comparable in size. Here is, I'm talking about a specific event, and you can see on the left that this is a Moore's Run, and this on the right is White Marsh. And these, it's like essentially the same storm because they're really close, so they will get storms at the same time, obviously. You can see that the observed and predicted discharge for Moore's Run is very similar, which is, this is like considered pretty well calibrated here. And this, even though this comes before the time has to be changed, somewhat, it's still, you can see the magnitude of the peaks are pretty similar. And you can tell the high, in Moore's Run, we had a higher runoff ratio for this event, and that would indicate to us that there's less infiltration going on than is going on in White Marsh. And also you can see from the time the rainfall happened to this peak, there is less time to the peak, and that could indicate like higher hydraulic connectivity in the watershed. Here is, you can see the peak comes a little later than we predicted actually, and that's probably because there's something that's adding some sort of roughness potentially to the watershed, or some other kind of factor that was not yet incorporated into the model when I did this run. Now, talking about the validity of using Kinneros, we were able to see that with calibrating, we were able to, as you see here with the Moore's Run, essentially get pretty good results of modeling in a humid environment, which is not what Kinneros was designed for. Which is really good news because it means that we can use this for various things within a research group within various areas. It makes collaboration a lot easier. In the past, when Kinneros has been compared to Geisha, they noted that Kinneros is more event-based, and Geisha you can run long-term simulations, but if you're just looking at events, there's no reason that you can't be using Kinneros. In the past, they've also said about you have to use different calibration parameters, which is not necessarily the best thing because they're a constant of the watershed. So for the same storm, you have to say that there's a different hydraulic conductivity. That's not necessarily a good thing, but it still can be like calibrated to show what's going on. So it's more like how it's handling the parameters. And we see that Kinneros can also be seen as more adaptable and sometimes can be quicker to set up if you're not super used to using Geisha. I'd just like to thank my mentor, Jim Smith, and Mary Lynn's another person who works in my lab who was super helpful. I'd like to thank Princeton's Hydrometeorology Research Group, and obviously UWIN for the funding and the grant from NSF and Colorado State, and really everyone, if I forgot anyone. If anyone has any questions, that would be a good time to ask.
Thank you, Laura.